Okay, so we will start with an example question today, uh, which involves the application of constraint relation, which we had discussed about before. Okay, so supposing we have situation like this. So we have a light thread going around a number of pulleys like this, and also connected to two blocks. So all the surfaces are smooth here. So we have this situation. So take the value of g as 10 meters per second square. This is, and mass of A is 15 kilograms, mass of B is 5 kilograms. Okay. The thread is standard type of thread, so it's massless and also inextensible. Because the pulleys are all smooth and also massless. So first of all, you have to find the ratio of the magnitude of the accelerations of A is to B, and secondly, find acceleration of E in meters per second square. Okay, so anybody got the answer for the ratio yet? Yes, that is correct. Yes. Anyone else? Okay, Harshal, Vasisht, and Diti, that's correct. So now come to the second part. Calculate the magnitude of the accelerations. Oh, actually, the ratio of A is to B will be 1 is to 3. Okay, not 3 is to 1. So let's understand that. So single string, so uniform tension acting everywhere. So at some point of time, if A is instantaneous velocity is VA and instantaneous acceleration is like this, B's instantaneous velocity is like this, and instantaneous acceleration is like this. The most convenient thing is to express the virtual power theorem. So virtual power theorem, the net power delivered by tension should be equal to zero. So power delivered by tension on E, on the block E, you can see that there is a total of 3T acting horizontally and is moving with VA. So plus 3T VA. And on the block B, you can see this tension T and it's moving down. So this is minus TVB should be equal to 0. So VB is equal to 3 times VA. So differentiate. So acceleration of A is to acceleration of B is 1 is to 3. Okay. So some of you have reported the answer is 3 is to 1. Just make that correction and make sure you understand that this will be 1 is to 3 and not 3 is to 1. B will be having 3 times the acceleration as A in magnitude. Now next you come to the free body diagram equations. So for the block E you can see that it will be 3t is equal to mass into acceleration, because there is no other horizontal force. Only the other forces are purely vertical. These two balance each other. On B, however, there is weight. So 3t is equal to mass of A was 15 kg into acceleration of A. This becomes our second equation. And for B, we have weight minus tension is equal to mass into acceleration. So 50 minus t was equal to 5 times dv. So that's our third equation. So these are the equations I'm getting, just cross check. Now what you can do is you can write this as t is equal to 5 times acceleration of v, and then substitute this here. So that is, substitute this v and substitute this over here. So we have 50 minus this is equal to, vertically downwards, this is horizontally like this. Okay, so hope the question is clear to all of you. That is solving of the equations, Baba. In this equation 3, substitute the value of acceleration of B as 3 times the acceleration of A. This thing. Substitute acceleration of B, AB, as 3 times the acceleration of A. So this side becomes 15 times the acceleration of A, and substitute the value of T as this. Alright. Now let's move on to another question. So we have this kind of a situation here. Second pulley also here. Okay, so we have a combination of two blocks in our system, which are like this. Now the angle that this thread is making with the horizontal at some instant is theta, and this is moving horizontally while this is moving vertically downwards. So the instantaneous velocity of A and B and the angle theta. So at an instant when the velocity of this block in the downward direction is, let us say, 2.4 centimeters per second, the angle theta is 30 degrees. So find BA at this same instant. So there is what we call a constraint relationship between BA and BB because of the thread length conservation over here. So you have to find that constraint relation, and from that you have to find. So what you have to understand in this case is that theta and V are both instantaneous quantities. I mean, both the speeds VA and VB as well as the angle theta are changing with time. Okay, so just work out this question quickly. Apply the concept of virtual power here. Okay, so hope you understood the relation here. So what you will ultimately get is this, that VA should come out to be 2 times VB by cos theta. This is the relation you should be getting. Okay, so in this particular case, that will be 2 times 2.4 divided by cos 30, that is root 3 by 2. So you can also write this as, so 3.2 root 3 centimeters per second. This should be your final answer. So let's see how we get this relation. So tension is acting like this over here, and same magnitude of tension is acting like this. So when you observe the block A, so on that block, your tension is acting at an angle theta to the velocity. So A is moving horizontally, but tension is acting like this. The velocity vector for E will be along the horizontal. So this angle is theta. Okay. Whereas for B, it's very simple. The net tension acting on it is 2t upwards, and its instantaneous velocity is VB downwards. So net power delivered by tension is plus TVA cos 30 degrees. Theta here is 30 degrees minus 2t into VB. So this should be 0. So as you can see, you get the relation which I told you, that VA is equal to, so you substitute, you will be getting this relation. Yeah, you can always substitute root 3 as an approximate value 1.7, and the answer will come 5.5 something, I think. But you can leave the answer in this way also, in terms of root 3, doesn't matter. Okay, next example, let's move ahead to something which has multiple threads. Okay, a system where not only multiple pulleys but also multiple threads. So we have a smooth inclined plane here, like this, and this angle is 30 degrees, and mass of A is 2 kilograms, mass of B is 3 kilograms. Let's make the mass of B more. Let's make the mass of B 5 kilograms. So taking G as 10 meters per second square, find the acceleration of A and acceleration of B. Okay. All pulleys are massless and smooth, and all threads are massless and inextensible. So start by again working out the ratio of the accelerations. That is going to be the critical thing here. Okay, so let us understand the constraint relation to begin with. Yeah, tell me the constraint relation first. Okay, so you have to understand that if this string has a tension T, then how much is the tension in this second string? This string will have a tension, let's say T prime, that should be equal to how much? 2T, because this is a massless pulley. There is T prime acting on it upwards and T acting downwards, but this is massless. So the net force should be zero. So this is our first important relation. So 2T is acting like this on this. Okay. So now when you work out the virtual power theorem, you can see that suppose we assume that B is coming down with some acceleration AB, instantaneous velocity VB. Then this one should be going up with some velocity and acceleration like this. Okay. So the net power delivered by tension should be zero. So on E, you can see that tension acting is only T prime equal to 2T and its velocity is in the same direction. Whereas on the block B, the net tension acting is 3T upwards. Okay. And it has a downward velocity of EV. So plus 2T VA minus 3T VB should be 0. So VA is to VB is 3 is to 2. So this becomes our first essential equation. Okay. Rest of all you can see is free body diagram. So for the block A, you have 2G cos 30 like this, 2G sin 30, because mass of A is given to us as 2 kgs. Okay. Some kind of normal reaction, you have tension 2T and you have acceleration of A. So you have 2T minus 2G sin 30 is equal to 2 times acceleration of A, or 2T minus 10 is equal to 2 times acceleration of A. So that's our second equation. Okay. And for the block B, it's very simple. You just have 3T upwards weight downwards, mass of B is given to us as 5 kg. This is 5g, and has a downward acceleration EB. So we have 5g minus 3t is equal to 5 times the acceleration of EB. So this is our third equation. Now it's a matter of solving these equations. Yeah, Tej, if you follow the free body diagram, you'll understand the string that A is attached to, that string is having a tension of T prime. Okay. Whereas the other string is having a tension of T. So how we are getting the relation between T and T prime? We are getting that relationship from the fact that the pulley, this one, this is a massless pulley. So you have to make use of that. Okay. This is the important thing here. This relation here. If this pulley is, let's say pulley P2 now, this is a free body diagram of P2. It's a massless pulley. So net force on it should be 0. That's how we are getting the T prime should be 2T. Hope this is clear now. Okay, so because the ratio of accelerations are like this, you can take acceleration of A as 3A, acceleration of B will become 2A. So we'll substitute that. So further, this equation, we can write this as 2T minus 10 is equal to 2 into 3A. This equation we can write as G also we have written as 10 already. So 50 minus 3T is 5 into 2A. Okay. So that's our equation 3. Now to get rid of tension and find this value of A, we'll multiply this by 3, we'll multiply this by 2 and add these. So 60, 60 will get cancelled out. And we'll get 100 minus 30 on this side is 60 is 18 plus 10 to are 20 E. So our acceleration will come out to be 70 upon 38 or 35 by 19 meters per second square, which means that the acceleration of E is 3A. So that is 105 by 19 meters per second square. And the acceleration of B is 2A. So that is 70 by 19 meters per second square. B is accelerating downwards, E is accelerating up the incline. So this is equation solving. You have to get used to this. Okay. In the more tricky type of problems, the simultaneous equation solving will require a little bit of patience and skill. Okay. But always keep in mind what I've taught you, that you write out your equations and then you start eliminating the variables. So between equation 1, 2 and 3, you can see that you have acceleration of A unknown, acceleration of B unknown, and tension unknown. So three variables. So you start by eliminating variables. Okay. So you make use of this ratio to eliminate these two. You write them as 3A and 2A, and then manipulate the equations to remove T or to eliminate T. So you get a single relation. So this is the sort of best method to proceed. Make a note of this, please. Okay, so always problems which have more than one pulley are going to be more challenging in terms of constraint relation as well as the solving of the equation part. So these are your JEE advanced type of questions. Okay. You will find plenty of questions like this in your booklet or in your module. Okay. Not only the in chapter exercises, but the main exercise 1, 2, and 3 behind the chapter also. Only thing is you have to just sort out the questions in the exercises with and without friction. So right now do the questions without friction. Okay. Now next we will move on to questions which will gradually combine some of the concepts that we have learned earlier. For example, we learned the concept of pseudo force earlier. Now here we'll see how we can connect the relation of constraint relation with pseudo force. So let us look at our next example. Okay, so we have this kind of a situation now. So all surfaces are smooth. This is smooth. This is smooth. This has a mass m1. This has a mass m2. So this is again a light and inextensible thread, okay, which is connected between a fixed wall and this block. Okay. So first of all, given that theta is equal to 60 degrees, we have to find the ratio of acceleration of 1 to acceleration of 2, the magnitude of acceleration of 1 to 2, and then given that m2 is equal to 3 times m1, find okay, so let's understand that in this particular situation, what's going to happen is this block is pushing this like this and at the same time getting pulled down itself. So what will happen is that the block has a tendency to slide like this, whereas this has a tendency to slide like this. So actually, after some time, this is what is would have happened. So M1, it has a tendency to, it slides down the inclined plane of the wedge M2 with, let's say, acceleration AR. Now why we are writing this as AR at W? With AR, that is the acceleration of M1 relative to M2. Okay. That means in the frame of the wedge, in this frame, you will see this block coming down like this. You will see it coming down with A relative. Okay. But in the ground frame, actually, it will be having some different kind of acceleration. So we'll come back to that. Okay. Because in the ground frame, what is going to happen is that the block was here initially. Now, after some time, the wedge has moved like this, and the block has moved here. So its direction of motion you can see is different. This is the acceleration of M1 in ground frame. So that is not going to be at an angle theta. So that is another important thing to understand here. The acceleration of the block M1 in the ground frame is not at theta with respect to the horizontal. Okay. By the way, theta is given to us as 60 degrees. So this angle. Okay. But relative acceleration, okay, that is acceleration of M1 in the wedges frame is at theta with respect to horizontal. So this is something very important to understand. And let us say that the wedge's acceleration in the ground frame is E2. So the wedge M2 slides horizontally with acceleration E2 in ground frame. Okay. So hope this situation is clear to all of you. Now, with this situation in place, first of all, constraint relation. So the constraint relation will come out to be A relative is equal to A2. So let's understand how this works out. Okay. So for this, we just have to use conservation of thread length, because there's just one single pulley and one single thread. So no need to get into virtual power and all that business. Okay. Just need to understand like this, that your system is like this. Now this has an instantaneous velocity Vr, let's say. Okay. And this has an instantaneous velocity V2. So Vr is the velocity of the block relative to the wedge. That okay. So in small time dt, so if this is how the system was at some time t, so at a new time t plus dt, what would have happened? This one would have just about moved a little bit, okay, through a small displacement. So this displacement would be how much? It would be v2 dt. So how much thread length is decreasing? The thread length is decreasing by v2 dt on this side, but then here this thread length would have increased by vr dt. So this should be, I mean, this thread length should be equal to m. So L is the thread length. So if you compare the first diagram with the second diagram, okay, so in the first diagram, if the total length of the thread was L, in the second diagram, this part, the horizontal part, the length has reduced by v2 dt. But the inclined part, the length has increased by plus vr dt. But the net length should be the same. So what this shows us, that v2 is equal to vr. So differentiate this. So it shows us that e2 is equal to e relative. So that's how we get the constraint relation. Okay. So make a note of the constraint relation first. And next up, what we'll do is, after constraint relation, second and third equation from free body diagrams. Okay. Your unknowns will be tension A relative A. So three unknowns will require three equations. So one equation is coming from the constraint relation. The other two will come from the free body diagrams. Okay, so I will show you this question from the beginning once. You have noted down the question. You just need the explanation below, or page. The explanation. Okay, so I'll just And also given to us that M2 is this one, M1 is the block. So M2 was 3 times M1. Okay. Okay, so fine. First write down the question with the explanation part, then come to the constraint relation below. So these two things here are very important to understand that the relative acceleration is along that inclined plane, but the acceleration of the block M1 in the ground frame will not be along that inclined plane. It will be at some other angle. Yeah, so Tej, have you finished writing down the question? Okay. Now write down the explanation first, then again we'll come to the constraint relation. Okay, so that's the constraint relation. Now next up, we have to make the free body diagrams. Okay. So now see, the next thing what you should do is free body diagram of M1 or the block. Now this one, it should be made in the non-inertial frame of the wedge. Okay, M2. Why? Because the this thing that we know, AR, that is the relative acceleration in the wedge's frame. So that is why we have no option. We have to make this free body diagram in the non-inertial frame. Whereas FBD of the block, the wedge, that is M2, make that in the ground frame. So do these, make these two FBDs and tell me the other two equations that we'll get. Okay. So after you finish writing down the constraint relation, please make these FBDs. Okay, so let's make the two free body diagrams. So our first equation that we were getting from the constraint relation, let's just write down here. A relative was equal to A2. So let's take that as A, suppose. Okay. So now, as far as the block is concerned, the block M1, we are looking at its free body diagram in the non-inertial frame of the wedge. Okay. So that frame itself is traveling along the positive x direction with an acceleration A2, which we have taken as E. So the first force we will show on this is the pseudo force. This will be a pseudo force. Okay. Then of course there is weight, okay. There is normal reaction, and there is tension. So these are the forces which are acting. This angle was theta, so here this angle will be theta. Okay. And in this frame, this block had a horizontal acceleration, sorry, acceleration relative to the block. So that relative acceleration, that was also A in magnitude. Okay. So along the incline, we have M1A, this angle is theta, cos theta plus M1G sin theta minus tension is equal to M1A. That's our first equation. Okay. And along this direction, we have M1A sin theta plus normal reaction is balancing M1G cos theta, the second equation. Of course, theta is equal to 60 degrees. So we'll substitute that in the end. So this was our first equation. Sorry, this is our second and third equation. Now we have one extra variable of normal reaction. So we will definitely need one more equation. Okay. So next we will make the free body diagram. So this was FBD of the block. Now next we'll make the free body diagram of the wedge. So if you go back to the earlier diagram, you will understand on the wedge there are a number of forces which are acting. Just pick up this diagram. You will understand that as far as the wedge is concerned, there is this block is pushing it down with normal reaction. So the wedge is pushing it up with an equal and opposite normal reaction. Then there is this tension and this tension is acting on this. Okay. So these are the forces which are acting on the wedge. Other than of course the weight of the wedge. So in inertial ground frame, if you look at the wedge with the pulley attached to it, the forces acting on it are normal reaction, tension, one more tension like this, okay, its own weight, and normal reaction from the ground, let's say n prime, and it has an acceleration of A2, which is equal to E. So when we make a proper free body diagram, we'll see that this tension and this tension, now they are such that this angle will be theta, because this angle is theta. The normal reaction will act like this on it, perpendicular to the tension. So this angle is normal reaction. Okay. And then of course there is the weight of this thing, m2g, and the normal reaction from the ground, n prime, and it has an acceleration e. या कॉन्टैक्ट फोर्स बिटवीन टू ऑब्जेक्ट्स ना बेटा, एक सरफेस पे ऐसा ब्लॉक रखा हुआ है, तो सरफेस ब्लॉक पे ऐसा नॉर्मल रिएक्शन लगाएगा, सो ब्लॉक सरफेस पे ऐसा नॉर्मल रिएक्शन लगाएगा, एंड दिस इज एट 90 degrees to this surface. Okay. So with respect to vertical and horizontal, see this angle is theta, yeah, this angle will be theta. That's all. Which ones? M1G, M1G तो ब्लॉक का वेट है, वो वेज पे कैसे लगेगा? The block, the weight of an object is a force that acts on that object. Na? How can it act on some other object? M1G is a force that we've already shown in the block's free body diagram. Na? See the FBD above page. How will M1G act on M2's free body diagram? It cannot act, na? Okay, okay. Again. Alright, so now let us write the equation for this one, the horizontal x direction. So we have t minus or t plus n sine theta, okay, minus t cos theta is equal to m2e. So that is our fourth equation. Okay. So now you can see from the beginning we have already eliminated two variables actually by introducing a. So we just need these three equations. Between these three equations now, equation 2, 3 and 4, we need to eliminate the variables t and n, and from that we can find e. Okay, and from that we can find a1 and a2, the acceleration of these two in the ground. So substitute theta is 60 degrees. So this becomes m1a by 2 plus m1g root 3 by 2 is equal to m1a. So minus t is equal to m1a. So we can write t here as m1a by 2. Bring this side. Oh, sorry. Take t the other side. And from this one, we can write normal reaction as m1g cos theta, so that is by 2, minus m1a sin theta. So this. So these two can be substituted in the fourth equation. And finally, you can also substitute the fact that m2 is equal to 3 times m1, which was given to you in the question. So this will become t into 1 minus cos theta plus n sin theta is equal to m2a. Now remember, m2 was given to us as 3 times m1. At least I think that is what I had given. Yeah, m2 is equal to 3 times m1. So this becomes t into 1 minus half plus n root 3 by 2 is equal to 3m1 e. Now substitute these two things from above. These two equations that we have got, we will substitute these two. So when we substitute these two here, this is becoming m1g root 3 by 2 minus m1a by 2, the whole thing into half, because plus root 3 by 2 into n, which is m1g by 2 minus m1a root 3 by 2 is equal to 3m1a. Okay. So keep the terms of g on this side. M1 will anyway cancel out. So we have root 3 by 4, this into this, plus another root 3 by 4. And keep the term of a on that side. So we have 3 plus 1 by 4 for this one, plus 3 by 4 for this one. Okay. So we have root 3 by 2g is equal to 3 plus 1, 4e. So we're getting e as root 3 by 8g. Okay. So this directly tells us that a2 is root 3 by 8g in the horizontal direction. But we still have to find out how much a1 is. Okay. A relative also now we know it's root 3 by 8g coming down the inclined plane at 60 degrees to the horizontal. But what is a1? That is the acceleration of the block m1 in ground frame. So this is still something we have to calculate here. No, Kunal, what is happening is that there is no reaction force as such. There is normal reaction. Normal reaction is a contact force. So pseudo force affects the contact force. Okay, but mg also affects. As you can see, n doesn't depend only on the pseudo force. It also depends on the gravitational force, no, on m1. Yeah, I'll give you time, but just a minute. Kunal, if you go to this earlier free body diagram, now look at this one, the free body diagram of this block. You can see that this n, it is affected by both the things, no? Mg and pseudo force. In fact, pseudo force is decreasing the contact because it's acting like this. If there was no pseudo force, then the contact force would have just been mg sine theta, sorry, mg cos theta. But now it is mg cos theta minus pseudo force's sine component. So the two are affecting each other. Okay, so let's take a look at both the free body diagrams. So first I'm coming back to this one's free body diagram, and the print is too fine here. So let me just take your time. First understand the FBD of the block in the non-inertial frame. and how we got these equations. Then we'll come to the second activity. Constraint relation is clear, I hope, Diti. Okay, so the first free body diagram is clear to all of you. Now the second one, for the wedge. Okay, so you reached up to this point, I hope. Now the final part, we want to find out the acceleration of the block with respect to ground. So this is where the concept of kinematics will also come in. Okay, so you'll have to understand it this way that I'm sure all of you know the relative motion equation, that acceleration of, let's say, m1 with respect to m2, or we can just write it like this: acceleration of block 1 relative to block 2 is defined as acceleration of block 1 in the ground frame minus acceleration of block 2. Okay, so this here is the relative acceleration of m1 with respect to m2, whereas these two are accelerations in the ground frame for m1 and m2. Okay, so hope this equation is clear to all of you. Now in our equation, this one only is the a relative that we have seen. Okay, so this quantity is actually like this. It is a vector coming down the inclined plane at 60 degrees to the horizontal. This is our a12 and its magnitude is e. Okay. Whereas what is our e2? That is this vector. Okay, and that also has a magnitude of a. And you can see the angle between them is 120 degrees. Okay. So we will make use of that. Okay. So now this quantity we know, this is the unknown. So A1 is the acceleration of the block with respect to the wedge plus the acceleration of the wedge. Or in other words, it is the relative acceleration plus A2. So magnitude of A1 will just become square root of, okay, cos of 120 degrees, because that is the angle between the two vectors. A2 was in this direction, A relative was in this direction. Okay. So this angle was 60, means the angle between the two vectors is 120. Okay, and both have the same magnitude. Both have the magnitude of this much, root 3 by 8g. So this becomes root 3 by 8g into square root of 1 plus 1 plus 2 into cos 120, which is minus half. So interestingly, a1 also comes out to be the same with magnitude. But that is only because that angle was 60. If the inclined plane angle was something else, then a1 would not have come out to be the same magnitude as a. Because this cos 120 term is minus half, that's why it comes out to be this way in the end. Okay, so just make a note of this finally. Okay, so next question, we will see a bit of revision of pseudo force concept. Okay, finish writing this down. Okay, next question. As I was saying, we'll do a bit of revision of concept of pseudo force through this question again. So this time we don't have the complication of the combination of threads and all that. It's just a little bit more simple. So on this smooth surface, you have this wedge, okay, of mass capital M, and a block of mass small m is placed on it. This surface is also smooth. Now we are applying some kind of horizontal force on the system. I mean, we are applying the force directly to the wedge. So given that capital M is equal to 10 kgs, small m is equal to 2 kgs, and theta is equal to 37 degrees, g is equal to 10 meters per second square. Find F such that the block does not slip down the plane with respect to the wedge capital. Okay? The block small m does not slip down the plane with respect to the wedge. Now think about this carefully, how this is possible. That while the wedge is moving, the block is not coming down the inclined plane, even though it's a smooth surface. So pseudo force will give you an idea about why this can be the case, but then it needs to be a certain amount of force we are applying. Okay. If we don't apply a minimum amount of force, the block will still slide down the inclined plane. So the hint is that make the free body diagram of the block in the non-inertial frame of the wedge, and from that you will understand how to calculate F. Okay, so let's understand this question in detail. So what is happening is we want that the system of the wedge plus the block should be moving together with common acceleration. There should be no slipping between them, or there should be no relative motion. So what we want is that this whole system, it moves with a common acceleration e, because as far as an observer on this frame is concerned, to this observer, this will look like it is at rest. Okay. In the frame of the wedge, okay, the block should look stationary. Okay, so there should be no relative motion. So that is why you start with the free body diagram in that relative frame. So what you do is you make the FBD of the block small n in the frame of the wedge, capital M. That is going to be a non-inertial frame. So in that frame, you can see that the frame is moving towards the left with an acceleration e, which we assumed something, okay, whose value we'll calculate just now. So this will experience a pseudo force like this. This is our pseudo force. Okay, and of course, the weight of the block is mg downwards, and the surface will apply a normal reaction, which is in this sort of direction. So you can also see that this angle here is theta, and this angle here is theta, because the inclined plane is at theta to the horizontal. Okay. So the condition for this to be at rest in this frame is that when you break down the forces into components, pseudo force के क्या components है? Up the inclined plane there is ma cos theta, and into the inclined plane there is ma sin theta. And mg के क्या components हैं? Down the inclined plane there is mg sin theta, and perpendicular to the inclined plane there is mg cos theta. A normal reaction is already resolved in the correct direction, so we don't need this. Okay. So for the condition for this is that for equilibrium in this frame, this component of pseudo force which is tending to push it up the inclined plane, it should balance this component of weight which is tending to pull it down the incline. So mg sin theta should be balanced by pseudo force's cos component. So in other words, our E should be equal to g tan theta. So that is our first equation. This is the condition for equilibrium. This is the condition that we get. Okay. And then next, all we need to do is calculate how much force we have to apply so that the system will have this acceleration of g tan theta. So in this case, this acceleration of g tan theta will work out to be 7.5 meters per second square, because theta was given to us as 37 degrees. Small m was 2 kg, capital M was 10 kgs, and g was of course the standard value 10 meters per second square. Okay. So make sure you understand this equation first. Okay, so now once you got this acceleration, next part to calculate the force, what we'll do is that since the block and wedge move together, okay, with common acceleration, okay, we'll make a combined F field of the block plus the wedge as one body. Okay. Because what that will do is that will make things very simple for us. We don't need to consider the normal reaction between the two because that's not no longer an external force. So there's only one horizontal force F. The rest is vertical forces of combined weight and whatever normal reaction from the ground. So this has to have an acceleration of g tan theta. So F has to be equal to m plus m into g tan theta. That's it. That becomes our final equation. So from this we get F has to be 2 plus 10 kilos into 10 into tan 37. So that's 3 by 4. So that's 12 into 7.5, or you can also write this as 3 into 10 into 3, yeah, 90. So 90 newtons is the amount of force we need to apply. Okay. So with this we conclude this session. So make sure you understand these last 2 or 3 questions. Now very important, your homework for this week is you have to complete H.C. Verma's exercise in laws of motion. Okay. H.C. Verma chapter Newton's laws of motion. Okay, there are 35 odd questions. So complete the exercise. Most of the questions are simpler. Yes, if you have completed HC Verma, you can start the module also. After that, start the module. Okay, so that's it for today's lecture, people. All the best. Yeah, make sure you attempt all the questions from HC Verma, and whatever doubts that are there, just keep them ready. We'll discuss in the next lecture. Okay. Next lecture we'll discuss any doubts here, but make sure you attempt all the questions from HC Verma, all of them. Okay. No, this week we have another lecture. That's why. This week we have that lecture. So in that we'll discuss doubts from HC Verma. Okay.